right, so to answer the question of is there a cheat? Yes, kind of. So if you wanted to fix your window without actually fixing the window yourself, you could hit the zoom button, go up or like all the way down to 0 and try zoom fit. Zoom is right beside window. If I hit zoom fit, this is poopy though. That's a horrible window for this situation. Because it's trying to graph as much of the parabola as it can. We don't care about that part. We don't care about negative time. We don't care about negative height. This is why zoom fit is a bad idea normally. So David, yes, there's a cheat, but it's not great.
So you could do zoom fit if you wanted, but if it looks like this, then you can just go.
You should go adjust your window yourself. Yes. All right, moving on. Let's try another one.
Oh wait, now I messed up with all my windows.
Graph this. Go back to y equals, clear it. Hold up. Go back to zoom. Go down to 6. Hit zoom standard.
What did I do?
Oh, yay.
That's going to reset your zoom.
We fixed it. Okay.
Now, it shouldn't be graphing anything right now because we deleted the graph. But we'll go back to y equals and type in x squared plus 2x plus 1. But we are not typing in less than 4. We're going to solve when that's less than 4. So if we hit graph, let's see if it's nice.
It's already pretty nice.
Ooh, pretty nice. How can we look at when is this function less than 4? Is that talking about the x equals 4 or the y equals 4? Is the output of the function the y or the x? The y. So we can go into y equals, create a line at y equals 4. Sorry, my zoom keeps changing. Or my focus.
Wait, so that 4 is always a y value?
It's what we're comparing it to. We're saying when are the output values of this function less than 4? So if you remember what we ended on yesterday, we ended calculating when will the amusement park make profit. And guys, that is seriously what people do for their jobs. They say, like, what do we need to set the ticket price at in order to make sure Cedar Point stays in business? Now, everyone do this with me. Hit second trace again. Because I got to make sure we practice this. In past years, we haven't practiced this enough. Because I know how to do it.
Oh, now we hit minimum because it's
No, we're not looking for a minimum. So I'm trying to get the focus to stop focusing. There we go. We're going to go to intersect. Desmos does this for you. Your calculator doesn't because you can't just like randomly go click on something. First curve. Notice it's on the parabola because it's the first curve I've typed. Go to as close to your intersection as you can. This one's easier. Hit enter, enter, enter because that's first curve, second curve, guess. It then should pop up with the word intersection and tell you what that is. So when x is negative, do it again. So we got x is -3, right? Hit second trace, go to intersect, and you could also just hit 5. Go to the right point where they intersect, as close as you can. Click enter, enter, enter. Now you can move the point in between. You get 1, 4. So now to graph this inequality, it's between -3 and 4, right? So we're going to graph our boundary points of -3 and what was, not 4, sorry, what was the x value on the last? 1. Now if we want less than 4, will those boundary points be included or not? Not included because it's less than. If it's not included, you do not shade it in. No, wait, less than 4. Do I want outside of those points or inside of those points? Inside of those points, right? So we're going to shade right here. And this is when y is less than 4. What'd you ask?
I asked
If
because
Jim's in the band
I have
room,
because in the band room all the ping pong tables are set up, and I just knew that.
I mean, you could probably anticipate that that's what's going to happen.
He said it's not an afternoon. I'm guessing he's going to move them.
I don't know. Maybe they had to be there in the morning for some reason.
Anticipation and
I know Rockbridge plays basketball some days, so maybe he just moved so they could play basketball today. They normally do it on Friday,
They
but I
also
don't
have a
know.
band thing tonight.
Yeah, the
That's
band
why
thing.
we're going to follow.
Ah, that would be
Maybe he does. I think what he did is move like the band instruments into the
Is
closet.
ping pong today?
Yeah.
to come watch us, there'll be ice cream. That we might fall apart.
What time is your concert?
The problem
I'm
is
supposed to go to Lifetime and work and train somebody, but I could maybe make it
no,
back
the
here.
problem
I'll
is
try to make it
that
back.
when we play butterflies, we're gonna fall apart.
We are. It's going to go so
Hey, band concert aside, does this all make sense? Because we're ready to move on to the next lesson.
Yes.
Now, put your covers on your calculator.
It's not off. It's super.
Put your covers on your calculator.
Solving systems of equations.
Oh,
Deja
no
vu.
fun.
Something doesn't sound.
Bum, bum, bum.
It's supposed to be red.
With the highlighter, it's yellow.
No, why are you red? But like when things aren't allowed, they're supposed to be red. You're right.
I really do wonder at what point you guys would run out of things to talk about. Because I don't know that it would ever happen. You're arguing orange versus red. They're both used as cautionary colors. So is yellow, though. Think of caution tape or caution signs. So, if we can move on and do math, f of x is x squared minus 2x minus 8. G of x is negative 2.5x minus 3. Make an xy axis on your paper, please.
Oh.
Are we going to
Pouting
graph
attitude
both
out
and
here.
see when they intersect each other?
Now, g of x should be fairly easy to graph, but a question you might be asking yourself before you make your axes, you don't have to stop, but a question you could ask yourself before you make your axes is, I wonder what output values I'm going to be dealing with. Because we know the y-intercept here is negative 3. We know the slope here is negative 2.5, so we can generally imagine that that line is going to be something like, like meh. Probably a little steeper than that. But, that's not my drawing.
And then the other
But then this positive parabola, so it's still pointing up, it's going to move down. I forget exactly what that does, but it's probably somewhere like that, or something like.
So we'll probably want more of a negative.
Well, so if we want to play out some of these output values, find some of them. I don't know, make a table. So if we try x is, I don't know, negative 2. Negative 1, 0, 1, and 2. Negative 2 squared is 4. Plus 4 minus, I think this is 0. I think I found a 0, guys. If my math is right. Negative 2 squared is 4.
Wait, is this for
the parabola, the blue. I think that's right. Double check on that.
No calculator, David.
Plus 2 is 3. Minus 8 is negative 5. You guys should be checking my math. Please do not trust me blindly.
Wait.
I don't trust me with my eyes open.
Wait. Well, wait.
This is negative 8. But it's negative, right? So negative 4 minus a negative really ends up being plus.
Yeah.
1 square is 1 minus 2, negative 1. Negative 9?
Wait. For,
Seems to be slowing down. We went down by 5, down by 3, down by 1. We might make the turn. Not the asymptote. We'll deal with asymptotes when we get to exponentials.
I feel like
Because that's a line we keep getting closer to.
I feel like
This is going to be we get closer to it, but then we turn around and get
I
away
feel
from
like
it.
there's an asymptote, it'd be getting like more fractiony instead of like.
Yeah, and then 2, we said is -8 again,
So we
so
found the vertex.
now we found the vertex, so we know the mirror behavior, right? So at 3, we'll be at -5.
Should we start graphing?
At 4, we'll be at 0. Yeah, so now we can graph this. What's up, Mr. Smith? You need something?
I've got tried really hard to make a mastery that would only last 44 minutes.
Oh.
That's impossible in my viewpoint.
So there's 4 that did not finish. If you are able to give it to them during AO/reading.
Yeah,
awesome.
Man, I had the new gym list. I have no idea where it went, so all I have to do is figure out where the kids are.
Actually, no, I don't even know if I shared it.
I don't think you did share it. You left them on our desks, but I don't think I have a copy shared. So if you could do that, that'd be sweet, so I can at least look at it. Do you like my solution with the Kleenexes? I was tired of kids like blowing their nose walking around the room. Go to the trash can, blow your nose, leave the tissue there.
Do you want us to do the other?
Yeah, we gotta find those intersection points, right? Yes.
Just go ahead and ask them.
You're saying lots of words, but not putting any of them together.
When are we getting our test back?
After Discovery Day.
Right.
We've 7th grade has been too frantic with trying to get mastered. I have just been like swimming upstream dealing with those guys, which they're great. I love them, but a lot of them have put things off and procrastinated.
Can you tell me what the other?
Sorry, I'm just getting a graph.
Oh my gosh, I grasped it.
You got
So my y goes down to -9. That's as low as my y goes.
Oh, I found one intersection.
Wait.
What?
Oh yeah, that was easy.
The other one will be harder to do though.
I need a geometry.
-2.5x minus 3.
The other.
So -2, 0, -1, -5. I should have changed those blue
Do you want
ones
me
to
to tell
something
you
else.
an intersection?
Sure. Well, no, not yet.
Huh?
So -2, or -1, -5, 0, -8, 1, -9.
The other intersection point will be harder to get because.
Once we find that vertex, guys, making the graph gets a whole lot easier.
Yes, because you can.
But then, -3 is my intersect, and my slope is -2.5. That's kind of annoying. I could really think of that as -5 over 2. Ah.
See, can I tell you a point down?
Yeah, you can.
2 -8.
It is 2, -8.
The other one's gonna be harder to do because it's like a weird.
Yeah, it's up by 2.5 to there. Up by 2.5 to here. Come on.
If only it was.
I know, it's my smartboard. Trust me, it's more frustrating for me. But we know that this point is going to be like out here somewhere, so it's
So.
crap.
You change the word.
Crap. Yes.
It bugs me that the 2 dots that one.
Oh, that should be red.
Yeah.
Yeah, sorry. Do you think there's another way that we could solve for the intersection points still without a calculator? Yes, just type it in your calculator. Duh, Mr. Hudson. So still without a calculator. What are the intersection if somebody asks you to explain, like, what are you talking about intersection points? I don't know what that means. What do you mean where they fit each other?
Like where they intersect each other.
Well, okay, define a word with the word.
Where they cross each other.
Okay, keep going.
Where they have equal points.
What do you mean equal points?
So like they're like the y. Couldn't you have the share from one y is equal to the other y? Couldn't you have them equal to each other?
Ah, so if we make the functions equal to each other,
Oh.
we could solve this by algebra.
So easy.
So wait a minute.
Add to graphic.
So x squared minus 2x, that's not x, I'm thinking of the next number, minus 2x minus 8 equal to negative 2.5x minus 3. I'm sure they can because they're awesome.
Why did we not just like do that?
Now, what should we do first?
Do what?
Simplify it.
Well, we simplified. Okay, what do you mean?
Yeah, get rid of the non-exponential.
The non-exponential.
What you could
So like, do what?
What you could do first is get rid of like that just normal exponent. Yeah.
What do you mean? Tell me what to do.
So like add 2 to both sides.
Add 2? Add 2. So like add 2. Oh, 2x. That's kind of important to say 2x. Add 2x to both sides. Remember, I'm just going to follow what you guys tell me.
So then that way.
Mr. Estes, do you have a suggestion?
Because if you square root it later on, you don't have as much like random things.
You ready to be 8? How do we do that?
Plus 8.
I'm worried about this path. I feel like we're walking into a deep, dark forest of ice. And I watched Beauty and the Beast last night, and I feel like we're going down the path towards whatever that area is.
Should we get the normal x by itself?
Well, how can we get the normal x by itself if
Square root.
that's going to get messy?
That's a
What?
mess.
What?
We went down the wrong path.
What?
Now, wait, no, hold on. I said it's scary, but I mean, in the end, she like marries a prince. It's not necessarily the wrong path. It just looks scary right now. So hold up. Square rooting both sides is a poo-poo idea, right? Shh, let him get there. Athena? You're trying like a guess and check method?
Remember that one time we guessed and checked?
Oh, make that like 1x? We could double everything, yeah, if we wanted to. We can multiply everything by negative 2 if you wanted to. We can do anything we want.
It looks like some kind of problem I've seen.
We know that the x is negative from the graph.
Okay, well there's 2 values, right? When else are we doing something with an equation that ends up with 2 values? Sophia? What if we pushed it all to one side and created a new quadratic?
Oh, subtract x squared, and so then it'd be quadratic.
Oh, don't make everything negative. You're right, you could. But that's gross to work with. Make everything as positive as you can. So if we add 0.5x to both sides, subtract 5, add 0.5x to both sides, subtract 5.
Do we have to solve that?
Your attitudes are lovely.
I mean, we know how to do that, but it'd be easier with the calculator.
I'm glad calculators were invented.
So, hold on. Sophia took us down this turn off the path. So we know x and x. We got to multiply to make negative 5.
And add.
So one of these has to be negative, right? Because we have to add to make positive, multiply to make negative.
I don't think that's okay. Wait, that's not possible, right? Mr. Estes is nodding. So,
Can that be solved?
yeah.
It's not going to be solved.
Estes is gonna give
Oh,
us the
2
Estes.
and 2.
Wait, 2 and 2 and a half
Negative 2.
is off of each other by a half.
Oh.
So negative 2 and positive 2.5. Now, hold up. Let's play out the what if. What if this totally seems unsolvable?
Put it in a calculator that you have.
Do they don't intersect. They don't put in the plane thing.
Put it in the plane thing?
And-
Oh, the square, the
Yeah,
diamond, the... Okay,
yeah.
What else? What if it really, really seems like it's just not going to work out this way of factoring? Ah, so let's try another route. So if we did x squared plus 0.5x
We could always get like
equals positive 5, right? That was our first step for complete the square, is get rid of, or we like take a moment and we think about the hypothetical. But how do we then start complete the square?
x squared plus 1/4 x plus 1/4.
Ah, yeah, half of your b, right? 1/4 is half of our b.
And equals 5.
So then we have to think through, what would this equal? X squared plus, well, the 1/2 x, right? That's supposed to go to 1/2 x. So 1/16. So we're going to add that 16th to both sides. Right, so up here and up here, we really added a 1/16 to both sides. To make this true, Mr. Estes, do you remember how to do all this? Because I often forget. Complete the square is tough if you don't practice it.
Solve the quadratic.
Equals 5 and 1/16.
5 and 1/16?
I don't know.
Oh, wait, can we write that as an improper fraction?
What's 5 times 16 plus another 1?
50 plus 30.
90.
50 plus 30 is
No.
80.
Where did the 30 come from?
The 30
Hey, trust me. Hold on, write this down.
is
Trust me. Trust me. Write this down. Liang's already seeing why I'm asking you to trust me. Sorry. Terrible noise. As we've talked about many times before, fractions are often better than decimals. They're just easier for us to see things. When we go to square root both sides here, square rooting a fraction, oh, these are both perfect squares.
Oh, wow.
So this becomes x plus a fourth
Oh.
equals 9/4,
And
but
subtract 1/4, which
but remember,
is 8/4, which
plus
is
or minus. Plus or minus.
Oh.
So x equals a negative 1/4 plus or minus 9/4.
2. Wait, and negative 1/4?
8/4, so negative 10.
Because remember, we got to get rid of that, but then we would like to write this as the second term so that this covers both x values. So really x is, what did we already find x is?
Negative 2.5, positive 2.
Yeah, we already found the positive 2. And actually, we did already find that also, but that was the other way.
Wow,
These are the two ways that we will solve a quadratic equal to a linear. Right? In the one, hold on, we still got time. I'm going to get you out of here early. In the one way, it does factor out. But, especially if you have a defeatist attitude, and you're like, I can't factor this. You can always complete the square. It'll always work. It won't always be clean, but it'll always work. And we get the same answers.
Wow,
Nah, you don't need a calculator. Calculators are for
It
chumps.
totally doesn't let you do the problem.
Nobody
Well,
matters. Nobody matters.
Yeah, sometimes.
If you're to use
But
calculators.
these are the sort of things that like they'll need to know how to do on the state tests and like SAT, ACT. They love to throw those random problems. It's like I have to remember how to complete the square.
That is a messy problem.
It's actually a lot cleaner than some of the ones we solved. Because it worked out with those perfect square values in the fraction. If that didn't happen, it'd be real gross. Alright.
I saw Sasha Wolf from Blue Cheese, but I told her like to check your problem. Not
Yeah.